All right, welcome everyone to second half of 9.1, or it should be more like the third. All right, we've done most of the section. We just got a couple things to wrap up, a couple examples. All we've done so far is verified trig identities. We showed a bunch of different ways of doing that. We're going to do two more of these today, and then kind of just look at some other ways of manipulating trig expressions. And those other ways of manipulation will be useful later on. So let's move on to example 2 today, where it says create an identity for 2 tangent of theta cosecant of theta. So instead of verifying an identity, ooh, I didn't realize that my camera was a little not straight. All right. So create an identity for this. In the previous example, we just verified identities. Started with the left-hand side, got it to be the right-hand side. To create an identity, let's just start with the left-hand side and see what we can do with it. So we can put things in sines and cosines. We can look for trig identities that we can use, and so on, so on. So if we do that, well, then we say, all right, this is equal to 2 times tangent of theta. Remember going back to the sheet that you're going to have of trig identities. You'll have that sheet available on quizzes and on exams. And this is what it looks like, right? So again, if you want tangent in terms of sines and cosines, tangent of an angle is the sine of that angle divided by the cosine of that angle. So we're just going to do that. We're going to have sine of theta divided by cosine of theta. And then cosecant, we could look at the reciprocal identities. Cosecant is defined to be 1 over sine theta. And now the sines are going to cancel, which is useful because now this simplifies to 2 divided by cosine theta. So this is one such identity that you can make, that 2 tangent theta cosecant theta is equal to 2 over cosine theta. All right, so if we really want to be complete, we'd write the whole thing out. And this whole thing would be our answer. 2 divided by cosine theta. Or if you wanted to, right, there's multiple answers here. You could have answered 2 secant of theta. You could have answered some other things too, right? It's not saying simplify. It's just saying find an identity for this. And we did. Okay. So that's one thing you might see in the homework. I think you probably will see if I remember right. I think I signed the homework like last week or something. So I should remember what I put, but I don't. So one of the big things for simplifying in trig identities is going to be factoring. So a lot of people might be comfortable factoring like x's and stuff, but it can be more difficult factoring when you're dealing with trig functions. So we'll do these for practice. Right, if you have 4 cosine squared of theta minus 1, this is something squared minus something else squared. Okay? So again, off to the side, let's review. Difference of squares says x squared minus y squared is equal to x minus y times x plus y. All right, great. I got my full chair back. I had a cat sleeping on it that I didn't want to move. So likewise, this is something squared minus something else squared. Well, the first thing, 4 is 2 squared, and then cosine squared is obviously cosine squared. So it's that minus 1, that plus 1. And anytime you're factoring, it can be a really good idea to check your answer by foiling this out. If we foiled this out, we'd get this times this, which is 4 cosine squared of theta. Good. Then the middle terms are going to cancel, and the last term is going to be a minus 1. Excellent. So we know that we did factor it correctly. All right. We can do it again. 25 minus 9 sine squared of theta. And again, just like before, it's just, okay, the first thing minus the second thing, and then just write this whole same thing again with a plus. That's all there is to it. If you need review factoring, because factoring is going to be important in this whole chapter. If you need help factoring, because factoring is going to be helpful in the whole chapter, feel free to email me. I can give you some resources. All right. And we're almost done. One more simplify problem, 2 more verification problems, and that's all that's left for the rest of the section. So let's move on to example 4. Simplify cosecant squared of theta minus cotangent squared of theta. All right, and again, just like before, there's a lot of different ways to do this. One way to do this would be to put it in terms of sines and cosines and combine the fractions. Another way to do this is to use a trig identity. I'm sure there's even more ways of doing it, but these are the two ways that pop into my mind. And again, as a reminder, unless you are just a natural whiz at this, I don't think anyone says that word, whiz, you're not just going to know all the time what to do. You have to just try things. You have to do some steps. You have to see where it goes. And after seeing where it goes, maybe it'll look better, maybe it'll look worse. And if it looks worse, you go back and you try something else. If it looks promising, you keep on going. You really have to just do a lot of these. And the more of these that you do, the better you're going to get at them. And the more quickly you're going to see what to do. So we have a cosecant squared and a cotangent squared. So we look at our identity sheet. And again, I recommended that you mark that the first 5 of these groups, reciprocal, Pythagorean, quotient, cofunction, and parity, are 9.1. And then this will be 9.2, and then 9.3, I think, after that. And just find something that we can use here. Cosecant of theta squared minus cotangent of theta squared. Again, nothing looks too promising here. But over here, Pythagorean identities, they're going to be useful. Because we have an equation that relates cotangent squared with cosecant squared. Specifically, cosecant squared is 1 plus cotangent. So we could plug that in directly right here. Cosecant squared is 1 plus cotangent squared. Or, if we wanted to, just like we did before, we could rearrange the identity to be cosecant squared minus cotangent squared. Subtract the cotangent squared from both sides. You have multiple options. But we're going to use the identity that cosecant squared is going to be 1 plus cotangent of theta squared. All right. So the cosecant squared became this. And then we still have the minus cotangent squared from before. And now look, we have a plus cotangent squared minus cotangent squared. They cancel out. And we're just left with 1. All right. All right. 2 final verification examples to really tie it all together. All right, verify these. We're going full circle. This is how we started the section. This is how we're going to end the section. Yes, you can use the identity page on the exam and quizzes, and always. You can have it with you always. If you wanted to print it out and have that while you're doing it, you can. Or I will also include it on the quiz page on Canvas, just to ensure that you have it available to look at. All right, so finally, let's do 2 of the more tricky ones. 1 minus cosine squared of x times 1 plus cotangent squared of x equals 1. So again, you always want to start with the messier side here. So we're going to start with the left-hand side. The left-hand side's messier. And again, there's a ton of ways that you could approach this. If you wanted to, you could put everything in sines and cosines. That's our rule of thumb. That's what, if you have no idea what to do, try that, all right? If we can make it simpler before that, we can do that as well. And we just use an identity that could actually help us here. You don't have to solve it this way, but you could. We just use this Pythagorean identity right here. 1 plus cotangent squared of theta is cosecant squared of theta. Well, we have a 1 plus cotangent squared right here. Let's call this, okay, let's call this cosecant squared of x. And wait a minute, something over here looks familiar too, right? Off to the side again, remember, sine squared of x plus cosine squared of x equals 1. This is a Pythagorean identity. If we subtract cosine squared from both sides, this is exactly what we get. So we can always manipulate identities to be more useful to us. So 1 minus cosine squared of x is actually just sine squared of x. So really, if we just use trig identities here, it gets a lot quicker. So at this point, you should be saying, okay, Jason, sometimes you're saying put everything in sines and cosines. Sometimes you're saying using trig identities first. Sometimes you're saying all this stuff. And yes, there's always a lot of different ways of solving problems. And the more of these you do, the better you're going to get at identifying what's the easiest way. You could also have put this in terms of sines and cosines. You could also have foiled this out, okay? A ton of things that you could do for this problem. This is probably the easiest way. All right. Excellent. Yes, exactly. So what we have right here is we have sine squared of x times cosecant squared of x. Well, now we definitely want to write things in sines and cosines because cosecant has to do with sine. So this is sine squared of x divided by 1 times cosecant squared, which is 1 over sine squared. Ah, neat. They just cancel. We're just left with 1, which is that right-hand side. That's the identity we wanted to verify. We started with the left-hand side, rewrote some things, and showed that it indeed equaled the right-hand side. All right. So now this next one's probably the trickiest thing you're going to see in this section. Not the messiest. There's some messy ones in the homework, but the trickiest. And that's cosine of theta equals, or divided by 1 plus sine of theta equals 1 minus sine of theta divided by the cosine of theta. All right? So this problem illustrates something new, a new problem-solving strategy. Again, I'm trying to teach you as many problem-solving strategies as you can so that you can kind of figure out when to apply each one when you're doing the homework. And hopefully you're not going to see anything new or too new on the homework that you haven't seen before. So we want to start with the messier side. I don't know which one's messier. You can just choose whichever one you want. It doesn't matter here. They're both equal, pretty equal. So I'm going to choose the one on the left arbitrarily. It doesn't matter. Okay. So we put everything in terms of sines and cosines. That's one strategy. Well, it already is. Another strategy was to look for trig identities. There's no trig identities to use. We can sometimes use algebra, but there's not really anything that clear to use algebra. So here we're going to introduce a new strategy. Let's write down the left-hand side again. So sometimes the right step, it lies in looking where we want to go. All right. So here, we want to get over here. We want to get to the right-hand side. So there's a couple of ways of getting there. One way of getting there would be to say, okay, we need a cosine in the bottom. Let's put a cosine in the bottom. Multiply by cosine over cosine and see what that does. That'd be one strategy, and that'll get you to the right answer. We could say, well, we need a 1 minus sine on the top. Let's put a 1 minus sine on the top. And again, that'll also get you to the right answer. So me personally, I like the idea of getting a 1 minus sine, because I notice if we multiply a 1 minus sine on the bottom, we're going to get a difference of squares, which is easy to work with. But both ways are going to be right. Let's just try to get either the numerator right or the denominator right and see if we can cancel out all that extra stuff. So if we multiply by 1 minus sine of theta on the top, then we also have to do it on the bottom. Right? We're multiplying by 1. Oh wait, I can do air quotes down here. We're multiplying by 1 in a way that we can rewrite things. So on the top, let's leave that factored. Cosine of theta divided by times 1 minus sine theta. And the reason I want to leave this factored is my gut says something's going to happen with the cosine, because we want the 1 minus theta by itself. Look at where we want to go. And the denominator I'm going to FOIL, because again, on the bottom we want just a cosine, so it's not going to be useful in that way. So if we FOIL the bottom, it's a difference of squares. We're going to get 1 minus sine squared of theta. Again, this is why we did this example problem, this example 3, practice with difference of squares of trig functions, because we have something really nice. And again, think of where you want to go. If you don't see the right next step, think about what we want. We want to get to the right-hand side. The right-hand side is just the cosine. Is there any way to relate the denominator with cosine? And if you don't immediately recognize what you can do, if you think, okay, we need to get the denominator in terms of cosine, that can help. Because again, we're going to use a Pythagorean identity. Just like up here, sine squared of x equals 1 minus cosine squared of x. We could have also have rearranged this to say cosine squared of x equals 1 minus sine squared of x. Ah, that's our denominator. So our denominator is just cosine squared. And when we write that down, it's going to look really exciting. Because what did we want on the top? We wanted a 1 minus sine of theta. We have that, just with an extra cosine. What do we want on the bottom? Cosine. We have that, just with an extra cosine. Well, if there's an extra cosine being multiplied on the bottom and an extra cosine being multiplied on the top, boom, boom, we just get some cancellation. The top is just 1 minus sine of theta. The bottom is just cosine theta. And lo and behold, that is exactly what we wanted. That is our right-hand side. And we verified the identity. Okay? Very, very important thing on this one. You have to work only with one side. If you try to work with both sides on the same, there's a couple pitfalls you can fall into, some logical fallacies. And we don't want that. Fallacy sounds too much like fail. So none of that. And that's the whole section. All right? We'll be starting 9.2 tomorrow. If you have questions, let me know. 9.2 will be put into next week's module, so you won't have to worry about that until spring break time-ish. Hope you enjoyed the video. Hope you enjoyed learning some mathematics. And have a good day.